All right. Do you want me to start the introduction, Amit?
Yeah, go ahead. You can do that.
Great. All right. Well, thanks for having me on the Farmington Hills Salesforce Developer User Group Salesforce Apex Hours. My name is Daniel Peter, and I'm doing a Dreamforce demo on Einstein Intent. So I've been working with it a lot lately. So I'm excited to share with you a lot of the stuff that I've learned about the Einstein Intent API. I'll tell you a little bit more about me, but first, let's have Amit introduce himself too.
Yeah, thank you, Daniel. So, hi everyone. My name is Amit Chaudhary. I'm the organizer of the Parliamentary Salesforce Developer Group. And recently, I'm also become a Salesforce MVP, and I'm also active on Salesforce Developer Community, and I'm also blogger at amitsalesforce.blogspot.in. So, I will not take too much time. So let's hand over it to the Daniel so that Daniel can give his introduction and talk about the Einstein. Go ahead, Daniel.
Congratulations on MVP, Amit.
Thank you so much, Daniel.
Okay. So in case you don't know who I am, I was awarded Salesforce MVP for the second time. I've got 22 Salesforce certifications. My day job is I'm a lead applications engineer at Canaan. We're a Salesforce ISV. We build a cloud ERP that installs on top of Salesforce. I run the Bay Area Salesforce Developer Group in San Francisco. I've been doing that for a couple of years. I'm an organizer there. So Einstein Intent is part of a bigger picture of many Einstein services that are available. There's this umbrella called Einstein Platform Services, which are the things where you can build custom apps. This doesn't include, Einstein for Sales Cloud, Service Cloud, things like that. These are just the platform services, which are APIs you can work with. So under Einstein Platform Services, there's another two categories. There's Einstein Vision and Einstein Language. So Einstein Vision is pretty exciting. That lets you do image classification and object detection. Won't be talking about those today, but some of the same concepts apply there. And then under Einstein Language, there's Einstein Sentiment and Einstein Intent. And I think Einstein Intent is a lot more exciting to me than Einstein Sentiment, because you could basically build sentiment with intent. Intent is like a custom classifier that lets you do anything you want. So that's the one I'm going to be focusing on today, is Einstein Intent. This isn't something that Salesforce, Salesforce isn't the only one doing this. This type of stuff has been around for a while. An example of that is Watson. So Watson, they don't brand it as something like intent. They just call it more generically what it is, a natural language classifier. But Einstein Intent is the same thing. It's a natural language classifier. So they've got a pre-trained model here, and you can very quickly just give it a try with their online demo. So they've got two different classifications, two different categories called temperature and conditions. So you can say like, what are the wind conditions right now? And you can ask this thing a question, and it says they're 95% confident you're talking about conditions. And this JSON response is fairly similar to the one you get with Einstein Intent. So just some big picture stuff where it fits in within the larger industry of AI and also within the Einstein Platform Services. So to be able to use any of the Einstein Platform Services, they all use the same type of authentication. There's two things that you need. When you first sign up, you need a one-time RSA private key, which you download. Don't lose this thing because you only get it when you sign up. This is like a little text file that you'll save. And then you need an ongoing token. So the reason it's ongoing is because it expires. So that key you keep forever, but that token will have an expiration time that you can set when you create it. There is a max value you can that it'll take. So you will have to update this. You can't just create it one time. It's a JOT, a JSON web token flow that lets you create this OAuth token, and you'll use your key that you downloaded to sign that token. So when you first sign up and create this private key, this is what it looks like. You go to api.einstein.ai/signup, and you can create your account with Salesforce or Heroku, and it's tied to your email address, and then it lets you download this key. Once you have that key, what you need to do is use that to sign this request. So this is right out of their documentation, but you can see you build this little payload with your email, the URL that you're going to be using. This is always going to be the same, and then some expiration time. And what this does, it creates this little payload, and you use your RSA key to sign that payload. And so when Einstein receives that payload, they can decrypt it. They know it hasn't been tampered with. They know this is a legitimate request, and they issue you this OAuth token. Here's an example of how you would do that request with curl. And also you can find examples depending on what platform you're working with. You might want to get these OAuth tokens in Apex or in JavaScript. There's a link here on GitHub for some example of how you can do this flow in Apex. But the cool thing is there's an easier way to get the token for demos, and that's what I'll be using. They actually give you a UI, a front end that implements this, this key that signs your request and gives you a token. So you just go to api.einstein.ai/token. You put in your email address, you upload your key, you give it an expiration time, and click Get Token, and then you get this OAuth token you can use when it expires. Once you've got those tokens, or the key in the token, the first step, you kind of have a blank slate of your sort of AI workspace that you can work with. The first step there is to create some data set and upload it. So for Einstein Intent, this is a CSV data set. This is a simplified example based on some sample data that Salesforce provides. But you have two columns in a CSV. The first column is going to be what they refer to as examples. Oops, sorry there. The mouse was a little touchy. The first column is what's going to be referred to as examples. The second column is labels. So the way the classifier works is you give it a bunch of historical data in your examples and what the actual labels of that historical data are. So these requests came in, these could be like a Salesforce case. I need to change my billing and shipping info. Well, that's a billing request. I can't log in. That's a password request. And the idea is you create this data set, you train a model with it, and then when a new request comes in, maybe it won't say the same thing. Maybe it won't say can't log in. Maybe it'll say I can't remember my login. And it'll actually be able to predict with pretty good confidence that that's a password help request. That's the magic of the AI. So these data sets can be, comma separated or tab separated, or they can actually be JSON. JSON I kind of like because it seems a little more compact. This one is repeating, the CSV is repeating the labels over and over again, whereas the JSON just lists the label once and then puts all the examples underneath it. Either way, it's the same. You just upload your preferred format, get the data set into Einstein. So there's actually multiple ways to get data sets into Einstein. You can upload the file locally, or you can point to a remote.
क्या बोले? वो जो टेनिस कोर्ट है कुछ प्ले के लिए तो उसके ऑपोजिट वाला है ना
हेलो
फील्ड में
हेलो
हाँ 1030 पे आ रहा हूँ सर.
Hello guys, who's not participating can keep yourself mute.
Okay.
Hello, Daniel. Sorry, like in
Okay.
between, like you was muted and can maybe some we miss your this PPT things. So can you repeat one more time? So we were not able to hear you that time.
Sure.
Sorry for that.
Yeah, so should I start with this slide here?
Yeah, can you start with this slide basically?
Sure. So we were looking at the data sets. To get the data sets into Einstein, there's multiple ways you can do it. You can do a local upload, which is, the file exists at the same client location where you're calling the API, or you can do the remote URL. So you might have the data set sitting out on the cloud somewhere. You can upload it synchronously or asynchronously. Synchronous is going to wait until the file upload is complete, and then it's going to return a response. So that's pretty good for small files. For larger files, you can do the asynchronous upload, so it's not keeping that HTTP connection alive for a long time. It'll return a response with a data set ID and a status of queued or running, and you can just pull for that ID until it's finished. Besides that, you have the option of using a CSV, a TSV, or JSON. So that what this essentially means is there's 12 ways you can upload a data set. The intersection of all these 12 different ways you can get a data set into Einstein. So with that, I'm going to get into some demos. First thing I want to show you is just the Einstein documentation. So it's actually quite good. You can see here's all the API methods you can call. Earlier in the documentation, there's a lot of info, about background and what you can and can't do, how to create tokens, things like that. But here's the actual API methods themselves. I was talking about uploading a file. Here's examples of how you upload it asynchronously. Here's examples of how you upload it synchronously, things like that. So this will definitely be your friend when you're using Einstein APIs. So what I've got is a small Lightning app that I've built. And what this does is it queries. It queries the data sets, the models, things like that. Just so we have something a little more visual than the curl commands. So we'll be referring to this. So let's take a look at getting that OAuth token. So I've already created.
Hey, everybody! I just posted a new video.
I've already gone to einstein.ai.signup and created my key. I've already done this flow. I've saved my key locally. So now I'm going to create a token. So I put in my email address. I grab my private key, which is under here. And I'll give it some expiration. And it gives me this token, which I can paste into my app. And then my app will be authenticating with that token. And showing me the data sets and models associated with this key. If we want to do some curl commands, so if you look at the Einstein documentation, they give you these examples on doing some things with curl. I've got a little notepad here with some of these curl commands. So what I need to do is just update in the header. We give the authorization bearer header with our token in there. So I'm just going to quickly update all my tokens with the token I just created. So when we make these curl commands, they will be authenticated properly against the right Einstein Platform Services account with the right data sets, the right models, all that stuff. Okay. So the first thing I want to show you is how to upload a data set. So you can see here, if you post to this URL with your file name, you can get a data set into Einstein. So weather.json is an Einstein demo file that they provide. I've already got this file loaded into a JSON editor. Oh, I thought I did. I guess not. Let's load it. So I'm going to load this into this JSON editor online really quick. We'll take a look at the raw data that we're going to be putting into Einstein. So we can see we have this particular one it's similar to the Watson one. It's related to weather, but it's got 3 labels: current weather, 5-day forecast, or hourly forecast. So the idea is somebody's asking a question about weather, and we want to predict, should we show them the current weather, an hourly forecast, or a 5-day forecast? So we can look into these examples, and here's all this, historically when somebody asked, is it snowing in Denver? That was a current weather question. Historically, somebody says, how does it look tonight? Maybe they prefer an hourly forecast. So that's our raw data there. So what we're going to do is we're going to take that raw data and send it into Einstein. So I'm using the synchronous upload. So when I send this request, you'll see it sits here for a bit and waits until the thing's finished. And we can see it succeeded. We can see there's 29 examples, this type of thing. So if we go back to this little UI that I built and refresh it, we can see here's our new data set. Oh, I'm sorry, it actually has 73 examples. I think it hadn't finished calculating yet. And here's our data set ID. So this will be important for future calls against this data set. And there's our 3 labels that we were looking at. So if we want to get that data set, we can get some information about it. I'll just copy the ID. I'll put that data set ID in here. And let's take a look at what that looks like. So here's this data set that we just uploaded. We can copy the JSON response, paste it into this formatter. And so it just gives us some summary information. It tells us the number of examples and labels in that data set and gives us a little bit of a summary about each label. So that's the type of thing you would want to query if you're building some UI, such as this. You can also get all data sets. So that's going to be very similar to what we just saw, except it's going to be a list of them. So there's, a couple of them: succeeded, succeeded. And you can also delete a data set. So if we take our data set ID here, we can do an HTTP delete with curl. And we should have just wiped it out. So if we refresh this UI, we can see that one we added is gone. But we actually want a data set for our demos, so let's go ahead and create it again. All right, now we have a data set that's back. So there's a way, your data set isn't a one-time upload. You can actually append to it. You can add to it over time. So they give you a method which lets you create examples from a file. And what this will do is it'll allow you to do incremental loads. So if you look, if you remember what our weather JSON file looked like before, we have an update file which just adds in, to the existing label current weather, it adds in one more example. So what we can do is, use this, this method to add in one more example into the existing data set. So then if we come back and look, we have 73 examples. If we refresh, we should have 74. I think there's a bug here. This isn't working. I'm not sure why. I need to look into this some more. Apologize for the glitch. Yes, so we have our 74 examples now. So, you can create a data set, you can add to a data set, you can delete a data set, but really to do anything with these data sets in terms of AI, we need to create a model. So training a data set is creating a model for the first time. Let's go ahead and try that. So let's grab our data set ID. Yeah, this app is not happy for some reason. Okay, so we're going to grab our data set ID, put it into our form post variable here. We're going to post to Einstein API and tell it to train this data set. So you can see the status is queued. If we come back here and refresh, we can see it's running the training for this. This actually does take a little while, so I'm not going to wait for this one to complete. I've got one that already exists, right here that I've done previously. So we'll probably work with that one. By the time we're a little bit later in our talk, this one will probably be done. You can also retrain an existing data set. So the point there is you've already got a data set that exists, and the reason you might want to retrain it, there's basically two reasons. You might have added new examples to your data set, or there's actually a few options. So you can train multiple copies of a model. You can, with a given data set, you can create many models, and perhaps they're all using the exact same data set, but you can change a few parameters. You can change the epochs, which is like how many iterations it's going to do. The more epochs, the more accurate. You can also change these training parameters, the train split ratio. What that does, it allows you to, so this is going to happen by default. What it's going to do, it's going to take 80% of your data and train the model and 20% to test the model. If you want to change that for some reason, you can. So that's some reasons you might want to create multiple models with, with these train and retrain data sets. So this is a very powerful feature. This is what allows Einstein to get smarter, and this is the concept of feedbacks. So feedbacks can be, you do a prediction, like in our Watson demo, we said, what are the wind conditions right now? And it's telling us 95% accuracy, it's conditions. Well, what if it was wrong? What if it said 95% accuracy, it's temperature? The feedback lets you say, you gave me this prediction, but actually this would have been a better prediction. So the way you do that in Einstein is you create a feedback example. And to do that, you actually give it the model ID that you ran the prediction against. You give it this document parameter, which is actually synonymous with example. They call it document for some reason, but think of it as an example. And then the expected label is the label for that prediction. So we can actually try this in Einstein with this demo. We can come in here against this model. We can run a prediction. We can say, you know, how hot is it sometime, and predict. This doesn't seem to be working. I'm going to grab this model ID and do it with curl. So this is the prediction right here. If we put in the model ID, we can say, we've already got something in here, so I'll just run this prediction. So you can see it gives us some probabilities. I'm going to actually paste this into JSON editor. This is pretty important. So I said something like, what is the weather in Los Angeles? It tells us 98% probability it's current weather. Let's say for some reason we thought that should be hourly forecast. We could copy that. We can go to our method for creating a feedback example. We can say the expected label was actually hourly forecast. And in our example, we sent, what is the weather in Los Angeles? So that would be the document. And then we just want to make sure our model ID is the model we want to create the feedback example for. So we can put this in as the model ID. We can run this request. And if we come back here, I believe it actually adds another example to the data set. Yeah, I don't know. I need to look into this. I'm running a Heroku proxy, so I can do these with client-side callouts, and it seems to be crashing. Okay, yeah, we have 76 examples now, so. Succeeded. Okay. There's some summary methods, get all examples, get examples for label, get training status, get all models, get model metrics. What these do is they allow you to get a lot more details on the models. So what I've done around these types of things is I built some UI. If you look here, this is just the basic model information. But what this right here, this is some of the data you get out of the training status. You can also get some more details on the model, and then you can also get label level details on the accuracy of the model. So if we take, you know, for example, the training status, we can get that right here. And you can see, you know, that's where this information is coming from, the train split size, last epoch done, these types of things. It probably gives you more information than what you're going to want for every use case. So you just pull out the bits that you want, you know, to get some stats on your model. One thing that's fairly interesting is this confusion matrix, F1s and F1 score. if you look at the API for this, this is under the model metrics. So it's a little tricky to do something with that. Because of the format. So that's worth pointing out. So you can see here's this confusion matrix that it gives you. I'll show you this one. So, you know, here's what's really key to note is the index locations are important here. So you can see there's 3 labels and 3 F1 values. So index location 0 is F1 value 0, index location 1 is F1 value 1. So you got to line these things up right when you present them based on their index location. Similarly, the confusion matrix as well. So when you're looking at F1 0, label 0, confusion matrix 0, line those things all up, and then when you present them, you know, you get this kind of a presentation that's readable. So that's just one little bit to keep in mind in terms of visualizing that API. I'll go over the confusion matrix too a little later and tell you what these numbers mean. But right now I just want to show you sort of how to get them out of the API, how to read them and put them into your UI. Okay, so that's kind of the basic usage of the APIs. So I'm actually going to go into a little more detail on some of these things, like you know, how do you prepare your data, because that's really key in increasing the accuracy of these models. You can see the test accuracy is 63%. You know, how do you get it up to 70, 80, 90%? That's going to be through your data prep, what data you select and how you transform it. Okay, so we saw some of these scores on the quality of the model. There's 3 different numbers that are pretty important to focus on, and they're sort of they drill down more into deeper levels of granularity. So the first one is the overall percentage, and that's the train and test accuracy. I would recommend just looking at the test accuracy. The training accuracy isn't that meaningful. What's really meaningful is it's partitions off 20% of your data where it knows the actual values of that data. It runs them back into the model and it says, do I get the expected result out? Because I knew what the actual result was. So that's a very powerful built-in feature of Einstein, is giving you back this test percentage. So take advantage of it. Try to get that test percentage up as high as you can. And you know, it's painful to have to manually test, to have to run lots of hypothetical scenarios back into the model. So by this running the actual scenario back into the model for you, it's very fast. You just get a score on your model automatically. If your percentages aren't good, your overall percentages, the next level you can drill in is the F1 score for each label. And this is returned like as a value from 0 to 1. So you want to get that as close to 1 as you can. And just to tie that back into, you know, this example, these are those F1 scores. So what this is telling us is, you know, current weather is kind of the easiest one to predict. 5-day forecast is the next easiest. Hourly is a little bit more difficult. So you can sort of drill in at this level, at your label level, and figure out what your model's good at predicting and what it's not good at predicting. The last thing is this confusion matrix. So there's an example here from Wikipedia, and I think it's pretty funny that it's called a confusion matrix because it's actually kind of confusing at first. So let's clear up some of that confusion. It's actually pretty darn simple. So the missing piece to understanding this is adding these labels to it. Without that, it's just you know, a table of numbers. But here's what the numbers mean. So across the top, we have the actual classes for the classifier. And across the side here, we have the predicted classes. And then here's the, the labels of the classes themselves. So what this matrix is telling us, in this example, down in the lower right-hand side, the class was actually a rabbit, and we predicted it was a rabbit. We got it right 11 times. When it was a dog, we predicted it was a rabbit once. When it was a cat, we never predicted it was a rabbit. So you can see we're very good with this model at predicting rabbits. We got strong rabbit actual, rabbit predicted. We've got weak dog and cat to rabbit. So that's good. But if we take a look here at dog and cat, when we actually had a dog, we predicted it was a dog 3 times. But when we actually had a cat, we also predicted it was a dog 3 times and a rabbit 2 times. So you can see this one's kind of weak. It's almost like, flipping a coin when it comes to predicting dogs. And, if we look at the cat example, we actually have a cat. We predicted it's a cat 5 times. We actually have a dog. We predict it's a cat 2 times. So it's a little better. So looking at this, you can kind of see, well, rabbit's the best, cat's the next best, dog is the worst, and cat is pretty good at predicting if it's a cat, okay at predicting if it's a dog, but this rabbit right here is like that's its strong point, is if it's actually a rabbit. It's not going to get that one wrong. So the overall quick glance at this thing is look down this diagonal right here and look for very high numbers, and then look outside of the diagonal here and look for low numbers. And that's like the quick glance at, is this thing a good classifier or not? And then you can kind of dive into it and say, well, what areas is it not? What areas is it strong and weak at? What that'll do is it'll let you refine your model. How do you refine your model? Well, we don't get a lot of knobs and switches in terms of what we can do with the Einstein APIs, but the way you prepare your data actually gives you a ton of flexibility. So we need to create this file that has labels and examples, but the input data that goes into creating that might be very different than the output data. So I have some considerations here with data prep. Some things you might want to do are to clean your data, combine data. So you might have some things that are very similar, but they're a little bit worded a little bit differently. You might want to lump those into the same category. You might want to reclassify things. So you might want to make new categories based on something, a product family or a case subject, something like that. And then you do need to deduplicate examples. I'll talk about why we need to do that. Same thing with labels. So the deduplication becomes very important because you need at least 5 examples per label, and duplicates don't count there. And what Einstein will do is if you put duplicate data in there for your examples, it's going to grab the first instance of it and use it. And then the subsequent instances that are duplicates, they're going to drop out and not get counted. And the problem with that is that might make some of your labels drop below the 5 example per label because those were duplicates. So what you need to do beforehand is you need to run a pass on your data, deduplicate your examples, and perhaps throw out any labels that have fewer than 5 examples. Otherwise, Einstein will give you an error. Also, the labels can only be 180 characters. This isn't going to be a problem most of the time. That's pretty generous. The other thing is they don't need to be words. So you could put a Salesforce ID in there as the label if you want. But the examples aren't the same. Examples, since this is a natural language classifier, examples need to be English language words for this to work and give you good results. And that actually doesn't have a 180 character limit. Those can be very big. I've done like many paragraphs in there. The problem is it seems to take exponentially longer, or somewhere between linear and exponentially longer, the more words you add to your examples. So this can be the difference between a model training in a couple of minutes, or a model training in an hour, depending on how many words you put in there. So part of your data prep might be to remove words that are extraneous, that don't have meaning. If you're pulling things, something like names of products, and maybe the product names weren't designed in a way that was very concise. They were designed for marketing purposes or something like that. You might want to pull out some of those extraneous words, and that can actually improve the quality of your model. So that's mostly what I have to say. I've got a few more things for the end, but I wanted to give plenty of time for questions. So if there's anything that wasn't clear that I didn't cover, now would be the time to ask.
Hey Daniel, one question I got from Jitendra Jha. So that is like why we are using Heroku proxy.
Yeah, good question. You don't have to use it. Most of the examples that you see online, they use Apex. So Apex works good for small amounts of data, but you'll hit governor limits, like if you've got large data sets, things like that. You could chunk it up. You could keep appending to your data set, but that can get slow. One challenge, I didn't talk a lot about it, but one challenge with these APIs, sometimes they're a simple API, but many of these post requests are multi-part form requests. So if you look, uploading a file is the best example. We're doing a multi-part form where we send the form data, which is all that JSON file, and we also send some form variables. So type equals text intent. So that's the multi-part. We've got data as one part, and we've got a form variable as another part. This looks very simple to create in curl, but in Apex, it's very difficult. So Salesforce has provided this HTTP form builder Apex class. You have to, and the multi-part form spec has boundaries. It has to do a lot of conversion from text to base 64 to binary, and you have to get that format just right. Basically what it does is it concatenates the form data with delimiters, boundaries, and also the form fields, and puts it in this format, this binary format. It has to be perfect. If it's even one character off, it's going to reject it. So using the Heroku proxy actually lets you do this in something like, whatever language you want, Node.js, Java, that has classes that handle the multi-part form encoding much more easily. There's even libraries out there that'll do it for you. So it just allows you to abstract out the complexity of building a multi-part form, as well as it gives you much bigger limits. And then the last piece is, for whatever reason, Salesforce hasn't given the ability to call the Einstein API client side. So they're putting in, they don't have the appropriate header in their web server that lets you do the cross origin request. So when you do the Heroku proxy, that opens up, you can open up that header so you can actually do a client side request. And client side requests have some advantages. They also have disadvantages, but some of the advantages are you can run for much longer. So, an Apex HTTP call out is going to chop you off pretty quickly, whereas a client side request can be very long running. It won't time out. You can also fire client-side requests in parallel. So there's sometimes you can have better performance if you're on a fast connection. So I would say I wouldn't recommend always using the Heroku proxy, but if you're doing larger things with Einstein, more complex, not only would you probably want to use a proxy, but you would probably want to do some of this off the platform altogether. So, you might want to run a scheduled job on Heroku that sucks your data out of Salesforce and trains the model and sends it to Einstein without any Salesforce interaction. Reason for that is, ETL is very costly to do on the platform, so you'd have very long-running batch jobs. But anyway, that's why I was doing that.
Hey Daniel, this is Reddy here. I have a question. So out of curiosity, in our data set currently, we are using text to text, right? Like you're using the search text as well as the label as a text. So I was just thinking like how would it behave when you use the hyperlink or like some Boolean or some special characters?
Yeah, I do have some experience with that. So for my Dreamforce demo, the text that I was training was product names, which had some of that. They had some special characters, things like quotes and slashes, and they had a fair amount of numbers. And so the Einstein Intent API will take anything. I mean, you can put numbers in there, you can put special characters. But what you'll see is when you train the model, the accuracy scores will be very low. So what I did is I did some simple ETL stuff. I put in a regex that only allowed upper and lowercase characters. So I stripped out anything else. I also stripped out like short words, simple words. I stripped out some very long product names. I just took a quick glance at the product catalog, and most of the time you could glean the meaning of the product like in the first 4 words of the product. So I just did a quick thing where I just kept the first 4 good words, and so I sort of put that product name on a diet, and that what that did is it made the model train a lot faster, and it also increased the accuracy from like 40% to 65%, something like that. So I think, the answer is you can put whatever you want in, but real, concise wording on at least the examples is going to create a better model. And then on the labels, it doesn't matter. You can have the label be anything. It doesn't have to be a word. It can be a number, foreign key, Salesforce ID, something like that if you prefer.
Okay. And looks like you need to use the Einstein Vision for like an image kind of processing, like image kind of prediction, right?
Mm-hmm.
So out of curiosity, what happens if you still use that with the Einstein Intent? Would it go to the confusion matrix scenario, or like what happens in that case?
I haven't worked much. We've actually got other people on our team here at Canandy that are working with the vision stuff. So I don't have a lot of firsthand experience with it. But is your question that do you want to use? So you're talking about the image classification, right? Not the object detection.
Exactly. Yeah. Like what happens if I try to use that with the Einstein Intent?
So you want to use, so when it predicts an image, when it gives you % probability that the image is a dog or a cat, do you want to take those predictions and run those as examples into Einstein Intent or something else?
Yeah.
Yeah, I think we've actually discussed this use case internally. And what we said was that you could kind of use intent as a intermediary layer. So you could take an image of a product, and it would give you a label or several labels of what that product might be, but it wouldn't give you a specific product name. It would just kind of point you in the right direction, and then maybe give you things like a general product category, and then you could use intent to sort of further hone in on the specific product. So maybe using these general product tags from image classification, plus maybe some attributes about the customer, the time of year, maybe even the customer's ordering history. You could try to hone in on more specific products that were more accurate. So we've only brainstormed about this, but I think there's maybe some good opportunity to link these two things together like that.
Oh, okay. Yeah, I know like it's not meant for that, but out of curiosity, I was asking.
Yeah, no, that's a great question. I'm glad that we actually have been discussing this and I had some answer for you.
Cool, thanks.
Uh-huh. Other questions? I've got some other things I can show you if there's no questions.
So one question from Yogesh, any possibility for the voice and the video recognition as we are doing with the text prediction right now?
Oh, that's a great question. Yeah, so the cool thing about the video is you can think of it as a series of still images. So I've seen, maybe you guys have seen Daniel Ballinger's demo of the self-driving car. So you can take still frames of moving stuff and run those into the image classification. It's becomes more a question of speed at that point. You get so many frames per second. How fast can you do classification on those frames? You usually don't need to capture all of the video. Maybe one frame every couple seconds is sufficient. But that's where this is headed, and that's very exciting. Real time, video stream, image processing stuff. That's the kind of stuff you use for, the things like the autonomous retail store, self-driving cars. And, I think Daniel Ballinger was kind of on the forefront of that. But we'll see more people doing that. We'll see people, thinking of creative ways they can take live video or recorded video, predict frames of it, and, feed that back into some real-time intelligence based on what they're looking at. There's no, I haven't heard anything of direct video being available yet, from Einstein platform, but maybe that'll be coming. Maybe we'll hear about it at Dreamforce. Maybe if not this year, maybe next year. In terms of the voice, I think that's another similar scenario. Actually, you just need a voice recognition API to convert that audio into text, and then you could feed it right into either sentiment or intent. So you can do some pretty exciting things with the image classification and the language if you put that intermediary layer in of grabbing frames or converting audio to text. So I think that stuff is actually possible right now if you don't mind introducing another set of services into the mix.
Okay. So anybody have any other question, guys?
Okay, I'll show a couple more things, and then if you guys have more questions, feel free. I wanted to plug my Dreamforce session really quick. This is pretty exciting because it's a real life use case. So I'm presenting Tuesday, 5 o'clock, Moscone West, 2009. This is the last session before the gala. So this is using Einstein Intent, we said, to blaze a trail to predictive selling. So we actually have a real customer called Tentcraft, and they have some very interesting products. I'll talk more about them at the session, but the cool thing is we're using real data. So just kind of a teaser of what that would look like. If I switch my demo to use that model, we can see, here's putting these APIs into action. So this is Salesforce CPQ and Lightning Experience. This is their quote object. We've got a quote. We've got some products related to it. We can go into the Salesforce CPQ screen. And this is the quote line editor. We can see those products here. And then I've added a custom button. Salesforce CPQ allows you to add custom actions declaratively. I've added a custom button for predicting, and we can choose some different models here. And when we click Get Predictions, what it's actually doing is taking all the products on the quote behind this overlay, is sending them into prediction based on, it's taking all the product names and sending it in like it's a sentence. And so what it gives us back is some labels of add-on products for this order. So you can see it's saying, they're ordering these things. Well, there's a 51% chance that we should be also trying to sell them a table cover. So you could click on this and add the items to the quote that way. So this is a pretty creative use, right? Like the uses, they call it intent. And so this is like, they're sort of branding it as like, what's the customer's intention coming in? Is it, customer service thing, or is it a lead that wants this product? But really this is a, just like we saw the Watson example, this, even though they brand it as intent, it's really a general purpose natural language classifier. So anything you can think of that you want to put into categories, you can use this to predict. So in this case, I'm using the upsell product as the category. So really, I think there's a ton of potential for this. If you can think of any tasks that you're doing in Salesforce, there's probably a way you can transform your data to, make those tasks more efficient. So that's just a little bit of a teaser for what I'll be showing at Dreamforce. Any more questions?
No other question I'm able to see on the chat window. So yeah, this is really nice, Daniel. Like most probably I will try to join your session in the Dreamforce this year.
Oh, thank you.
Me too.
Hey Daniel, this is Jitendra. Thanks for the session. It was very informative.
Oh, thank you.
Really, thank you so much, Daniel. This is really very good session, and I will going to post this on Meetup as well.
Hey Amit. Hey Amit, this is Reddy here. I just wanted to thank you and Daniel from Miami's Work Salesforce Developer Group for this session.
Thank you, Reddy. Thank you.
Thank you. Great. Well, you guys know where to find me. Hopefully, reach out on Twitter is probably the easiest way if you have any questions. I think it's pretty early for this technology, so we're going to hit a lot of snags. Most of these things are in beta, so just let me know. If you work with any of these things, let me know how it goes, any challenges you're having, and we can probably leverage each other to figure out what's going on.
Okay, thank you everyone. So next time we will again come back with one of the new topic in our Salesforce Apex Hour. Thank you everyone for the joining, and thank you Daniel for coming up, joining us as a speaker this time. Thank you so much everyone.
Oh, thanks for having me. My pleasure.
Thank you.
Thank you. Bye.